You good? We do have audio though? He needs to get some signs. Should say Danner's Automotive. Yep, there's the phone number. Don't call him for automotive help. If you need repairs, of course, bring him your car. Don't call him for automotive help. You contact me on my forum, right? ScannerDanner.com. Don't ring his phone off the hook. That's what's happening now.
You ever find yourself talking to yourself?
Yes, all the time. All the time. In fact, it's changed like to a point of it's become
diagnosable?
No. I actually was sitting in my kitchen one time and I was like, oh, gotcha. I didn't say anything else. But out loud, I said, oh, gotcha. Right. Like I'm talking to myself, but out loud, I'm like, oh yeah, gotcha. That's how bad it's gotten. So Expedition, yeah. That's it. Maybe you can add some insight for us here too, and this will be for our viewers. Our first car we're looking at today is a 2013 Ford Expedition with a driver's side low heat complaint. Those are known for the actuators that strip out, which is a 6-hour job, by the way. You got to rip the whole dash apart to get to it.
Driver's side heat.
Yeah, it's right in the center. It's in this center area. That Ford tech Make You Loco, I don't know if you ever watched any of his videos. He showed how to do it. It takes about 2.5 hours as opposed to 6, where you can take the center console out and drop the duct work at the bottom. Not take it out, but then you use a pry bar and you pry it down, then you can get your hand in there and you can take that actuator out. Nice. Now the one he showed though was on an F-150, and he said the Expeditions are easier, but he breaks the tab off the one side of the old actuator, leaves the one bolt. It's not ideal, and we would let, you know, this is my friend too, so we'd let him know that, hey, you want to do 2.5 hour repair, but he was comfortable with it because it was his friend's, and the ductwork holds it in place. So one bolt, and then the ductwork holds it in place. So that's an option rather than pulling the whole dash apart.
Okay, yeah, I can't do that this week.
Yeah,
anyway,
no.
So.
But he did say that he was about 1/4 gallon low on coolant.
He said he thinks he has a coolant leak too.
Yeah, and so maybe we just got an air pocket in the system. I don't.
He said once he had the AC charged is when he noticed it, because then it's like it can't.
Right.
You know, it can't cool down the. You know, if that motor ain't switching on that.
Well,
side.
He didn't notice the cooling part's fine. It's the heat.
Yeah, but he didn't notice that until he had the AC charged.
He did say that. And he doesn't know. He said it was a $1,000 repair. He doesn't know if they were in the dash or not, but he had front brake work done, the AC fixed, recharged, and a state inspection. It was $1,000, and that makes me think maybe they were in the dash. I don't know. I mean, if they were in the dash, that might be more than $1,000.
Yeah, unless he did pads and rotors all the way around.
Right. And then he said he did have coolant flushed at 100,000. He's owned it since new, because I was, worried about heater core. You know, 100,000 is a lot, but to wait for, I think we did ours sooner on Kristen's Navigator, which is basically the same setup.
Okay.
Okay.
Yeah, so I don't really know much.
Well, we're going to look at that first. That's the plan. We're going to go look at this no heat or low heat complaint on this 2013 Expedition. I'm putting the scan tool on this in preparation for checking mode door position. We should be able to see the temperature blend door position on the scan tool. So that's my hope. So I asked Caleb what scan tool he wanted to use, and he prefers the Autel for editing. Why do we prefer the Autel for editing, Caleb?
The resolution is like way better.
Ah, gotcha. The screen
way
resolution.
Better.
I got this birthmark on the side of my face, like right here, and it's like fertile ground. I know you're gonna use this.
For what?
For hair to grow. Yeah, it's like even gray, and even before I could grow a beard, it was the only spot on my face where hair would grow is out of this birthmark on this.
Funny.
It's weird how it's like that. When you get older, it's like the hair stops growing on your head and then starts growing out random places. I'll get one on my shoulder. Yeah, it'll get long. I yank that thing every so often. Okay, so we'll do a fault scan. This is the topology. Is pretty neat setup on the Autel. I like that, and the way that it scans. It's pretty fast too. I mean, it depends on the car too, but as you can see, it's running through these modules pretty quick. And then one of the things I like about this as I continue to use it is it gives you the definition. Like, I don't know what IC, that's probably instrument cluster, but if you click on that, it'll tell you, I'll have to wait till it's done its scan, I guess. It'll tell you, if I click on that, it tells you what IC means. Or ACM, what does that mean? Click on that icon and it will tell you. And I do have one fault in the HVAC system, so that's cool. And that was pretty fast, man. But IC, what is IC? Is the instrument cluster, cool. ACM is the audio control module. RCU is the audio rear control unit. And then the HVAC system is definitely the one I'm interested in for right now. Let's just go to that guy. Or we can view all of them. I'm not worried about teaching the tool right now. I think if I hit report, we can scroll through all of the modules. It shows it in a different way. Yeah, instrument cluster, there's 11 faults. Invalid, battery low, lost communication with PCM, lost communication with transfer case, lost communication with RCM. Remember, someone was in here and did some work, so there's possible that some of that is history. Hey, Steve, you're in luck. You're not in luck. Steve is my friend who owns this car, who I play hockey with. We'll have to put a meme in here, Caleb. And this meme says, I'm going to shoot this puck in your general direction. Wait till I share this meme with you, and you can put it in the video. This is the epitome of old man ice hockey. Anyway, we do have a left side blend door circuit failure. Circuit failure generally means it's an electrical problem. It's good and bad. It's good in that I'm not worried about like a head gasket and air pockets in the system. He did mention adding some coolant, which we talked about. He might have a little bit of a coolant leak, but that's not related. We have a temperature blend door circuit failure, and that's why we have heating issues on this left side. We'll go to that module in a second. I want to start this up and see if we hear the clicking that my friend Ford Tech Make You Loco, I'll put a link to his video on where he shows the temperature blend door replacement we were just talking about. I did a little bit of homework this morning, and some of my homework, sometimes, just like you guys, let's see if we got a YouTube video on information on the temperature blend door on this system. And that's what, you know what, if I see a Ford Tech Make You Loco video, he's the guy I'm gonna go to for sure if I'm working on a Ford. Super smart guy. Check out his channel. He's super smart. And one of the tests that he showed, let me close the door, see if we can hear this. I want to turn the climate control panel on, and I'll turn the blower down so that's not too noisy. What we want to listen to on the driver's side, I'm going to go full cold. We want to listen for some clicking here. I heard it. Oh, it's on auto. I don't want it on auto because we do hear some mode doors changing. When you're in the auto position and you go cold to hot, it will not only move the temperature blend door, it'll move the position of the airflow. Right now it's at foot, and you know, you can change it to defrost, foot and defrost, vent and foot, right? I'm leaving it on foot now just to make sure that we're not getting a mode door change, because I heard something here. I am hearing some movement. I heard some movement, but not clicking like my friend showed in his video. So let's go to the scan data now, see if we have a data PID for this temperature blend door. Oh shoot, you know what? I made a mistake too. And what brought this to my attention is right here where I have dual climate control status is not depressed. So what I did not remember, and now I do because I have one of these systems. My wife's car is a 2012 Navigator, same setup. For the dual climate control, when you first turn this on, well, when it's in the off position, it goes to a single mode. I do not have the passenger side being controlled right now, and now I do. So when you're just adjusting the one, it's doing both sides. So any movement I heard could have been the passenger side blend door, okay? But now that I have this, we'll leave that one at 80. Now that I have, I don't know why this says not depressed, because it should be now. I'm not worried about, don't worry about the data PID. Let's do the same test again now that we're in the dual climate control mode, because it should only be adjusting the driver's side now, not both. Let's listen. So there's full cold. I did not hear the same sound. That was Caleb's foot. Listen again, that's full hot. Yeah, no sound. Let's put this one at 80. No particular reason I'm picking that number. And then let's move this one now. Listen for a sound. I heard the click. You hear the little thud? Now listen again. You can actually, on the passenger side, it's a little servo motor. You can hear the motor clicking. Not in a bad way, but you can hear it. Let me see if I get my mic closer. You can hear the servo motor moving. So for you guys following me right now that maybe you don't have a high-end scan tool where you can view data parameters, don't worry about the scan tool right now. This initial test is one that anyone can do. You're just using your ears and understanding that a temperature blend door is simply a motor, a reverse DC electric motor with a position sensor on it. And it's probably 5 wires, I haven't looked, but typically they are, where you'd have 2 of the wires be in motor control. Reverse polarity means we'll power this one, ground this one to make the motor turn one way, and then we'll power this one and ground this one, reverse the polarity to make the motor spin the other way. And then the other 3 pins would be a 5-volt ref, signal and a ground. It's a potentiometer like every other potentiometer on the car. And by the way, this is chapter 7 material for those of you following along in ScannerDanner Premium and on my book. So I'm gonna go to the scan tool now, see if I can see that. This really isn't necessary. We have a code for circuit fault, and we know it's not moving because of sound. But I just want to show it to you on the scan tool too. Hopefully we have a door position that I can show you. So blend door position, that one moves. When I move the passenger side, you can see the blend door position number is changing. That's this middle one right here. You can hear it too. And then the climate control blend door position status, I'm not really sure. Let's try the driver's side now. I'm getting no changes. What I don't know is the driver's side, the auxiliary air blend door. I don't know. Or is it the climate control blend door position status? I think it's that one. And the reason I'm saying that, they're both listed as 0 and 255. So the 2 that I have check marked right now, they're both listed as a count. 0 to 255 is a standard binary coding number for an 8-bit computer, where it has 256 possible positions. 0 counting as 1, 255 being the max, so 256, standard stuff. But the blend door position on the Autel, clearly that's the passenger side, because as I move it, I'm pushing the passenger side button again. As I move that, you can see that. In fact, we could graph that for you guys, and I can graph this one too. As I'm pushing that button, you see the mode door is moving. It's a feedback circuit. This is a potentiometer. Very cool to see. You know, as I'm pointing this with my middle finger, I actually had a guy criticize me for pointing with my middle finger. I really didn't mean to flip you guys off here, okay? I'm just pick that finger. All right, passenger side works fine. I believe that our climate control blend door position at the bottom is the driver's side, and it is not moving. So now, unfortunately, I need to get to that, which is buried. And from my friend Ford Tech Make You Loco, from the passenger side, I'll have to have Caleb move. I should be able to pull that panel off and see the blend door actuator and the connector. Maybe the work that he had, it's possible they didn't plug in the connector if they did some dash work in here when they fixed his air conditioning. It is possible. If that connector is plugged in, then that doesn't bode well for the blend door actuator itself. We have a circuit fault. A circuit fault would be on the output side, the motor control circuit. I mean, typically it could be either one. You can have a circuit fault on the potentiometer part. You can have a circuit fault on the motor part. In either case, when you see circuit faults, we're talking about opens and shorts. And the fact that I have a blend door position is suggesting that that it's the motor part of it that is the circuit. Let's see, show you guys this code again. Did that just shut off? Oh, when I went into trouble codes, it actually changed stuff on the climate control panel. Left side blend door circuit failure. Left side blend door circuit failure. So B2266. All right. Yeah, I need to pull that off and see what we can see. Steve, my son wants to know, why would you leave expensive headphones sitting right there where everyone can see them? So you're inviting people to say, hey, break this window and take me. Before I do this, Caleb, one other thing. He told me the receipt for this. He had this done at NTB. I just wanted to see what was done with the air conditioning. Evacuate and recharge the AC, insert dye leak test. They were not in the dash. That's good to know. That means it's not gonna be unplugged. It's probably just gonna be a failed mode door, which kind of sucks. I'm talking to Steve now because it's a 6-hour job to get to this mode door.
Are we gonna be here for 6
No, we're not doing the repair. We're gonna pass this off to Danner. And I mean, honestly, the job needs to be sold too. It's gonna be whether or not Steve wants to do it. And the other thing too is, like I said, I'll reference my friend's video. To do it right, the whole dash has to be removed. It has to be disconnected. The entire part you're looking at has to be pulled back. So all of this right here needs to be pulled out of the way so you can get to the climate control box and change that part. We're not doing it. Yeah, so they were not in the dash, and you know, it's looking like it's gonna be a temperature blend door that's gonna need to be replaced, and it's a big job. And you know, it's possible that we can, why do we have an extra key in here, Steve?
For the people who take the headphones, they can take his car too.
As that truck went past, probably didn't hear that, Caleb said, so when the people take your headphones, they can also go in your glove box and steal your car? Is that why? I'm gonna pull this panel off. We're gonna look anyway, and then we're gonna probably make the call. And if I can get to the electrical connection, then that's great. If I cannot, then we're pretty much done until we figure out what my brother and Steve, my friend, decide they want to do. I'm really happy that I watched his video this morning because I know where it is. I've never done one of these, so without seeing that, I'd be in Mitchell and looking, and covers are another thing.
And you can see a ductwork right there and some screws to lower it down. There's some space between that.
Yeah,
and
see,
the
he has
floor
that trim
tunnel there.
panel off.
So maybe you can get it down far enough. This actuator only has 2 screws holding it in, which makes it even easier. We'll drop it down and then we'll slide on out of there, hopefully. So we're gonna definitely go ahead and try it before pulling the whole dash and the whole car apart for one little actuator. All right, so I'm warning you now.
Yeah, I was just making sure, like, because I can't move this, and I'm like, does this panel come off? If it does, it feels like it's gonna break. Don't want to break it, and I don't want to get buried in this job just to try to show you an actuator that I can't really freaking see anyway. I wonder where the passenger side one is. Is it up top? Yeah, I believe that's it. I think that I have to check service info here, and this helps when you've worked on stuff like this before, and I have not this model anyway. I mean, I've done plenty of dash work in my time, but I've just not done this particular car. This guy right here is the actuator. Can't get to it at all. Center console at least got to come apart, and it took the Ford Tech guy 2.5 hours to pull the center console. So he said about 2.5 hours to pull the center console and to do it from underneath without pulling the whole dash, and that's just, unfortunately, I can't do that. Let's go to Mitchell and see if I can get a diagram to show you guys that picture. It's the actuator, Danner. Yeah, unfortunately.
Dude, that is terrible.
That is like the worst picture ever. So 5 is what? 5 is the left-hand temperature blend door actuator. Is that with it upside down? They're showing that up on top. Floor duct is 2. So yeah, it's upside down. This is the floor duct. Yeah, it's that piece we're looking at. It's upside down. Can't get to it. Man, why couldn't it be the right-hand one? Because the right-hand one we can get to by pulling the radio out. But there's your shifter. The navigation system, climate control panel is here. Navigation's here. There's your passenger side one. Let's see what it tells you to do as far as R&R. So remove the heater core and evap core housing. And to do that, heater core, thermostatic expansion, removal and install. Yeah, you're pulling the whole dash. Position adjustable pedals, recover refrigerant, drain the coolant, remove the 2 front seats, remove instrument panel, disconnect the heater hose, remove thermostatic expansion valve, remove the 3 heater core and evap core nuts. Steve-O, I'm sorry to tell you this, man. You ain't gonna like this. Temperature blend door, main. That's the door. That's 8.7 hours of labor time. Temperature blend door main for the right side is 1 hour. Steve-O, why could it not be the right side? For the left side, you have to remove the entire dash. So yeah, I mean, I've shown you everything I can for this one. We'll try to update you guys as far as what happens. This might be one that my brother sends away. Unfortunately, just maybe pan the shop real quick, Caleb. Let's get a 360 of the shop. And you see how busy he is. And then let's get a shot of the parking lot too. You know, there are times where you have to say no. This might be one of them. But at least, you know, wherever my friend decides to take it, if my brother doesn't take the job, he can at least know that he's getting the right call. But take a look at the parking lot too. You know, all of these cars. Like, what a horrible, horrible design for Ford to do that. But there's literally nothing else I can show you guys. I cannot get to anything in there. And again, from what my friend showed in his video, it took him 2.5 hours to take this apart to a point where he could, you know, do the job. I mean, it took him 2.5 hours to do it. And that was the friend version. By friend version, it's really, you know, he even said for a customer he wouldn't recommend doing it that way. This is a friend, and I know Steve-O probably would agree to to something to save him some money, but either way, I can't really show you guys anything else. I think what I'm gonna do for my friend here, because we had all those fault codes for those other systems, is I'm gonna erase all of the codes. I hate that we don't have a final, you know? Like, what do we do with this video? Like, what do we do with it? It's not worth 8 hours of my time to do this job for this video. I'm not doing it. I know some people are gonna be like, oh, come on, Danner. No, it's not worth it. I got things I need to do, and this is not one of them. Steve-O, I feel bad. It's a huge job. And I'm bailing on you, brother. I'm bailing on you, man. Somebody else can do it. I mean, maybe my brother will agree to try to do the lower part job for my friend here, and we'll give you guys an update. But as far as what we're doing now, I'm just going to put this back together. I'll leave it up to them, and maybe we'll either update this video in some notes in the description, so make sure you look for that, or maybe there'll be a last piece where there's a new actuator in here and I can show you the mode door position. In fact, Caleb, what we could do is use Mom's car and show these exact same data parameters that we just showed and show the movement of the door. I don't know if that's even worthwhile doing, because we showed the passenger side working, so it would be no different. But I'm conflicted because of the depth that I would need to go into to prove this to you guys. And there's sometimes you just abort, and for us it's abort. We're done. So hopefully you guys learned something. Maybe you did, maybe you didn't. and I don't know, see you next time. We are back, and I said that I wanted to fill in the gaps here. One of the things we need to cover first off is, for whatever reason, my dogs are in here, and Penny is, she's been whining. She thinks we're going somewhere, but we're not. We're just doing a quick follow-up on some of the data PIDs that we saw on the Expedition, since my wife's 2012 Navigator is the same system. And then I wanted to do a final review of testing that blend door and showing how the manufacturer wants us to test it. So my HVAC system is what I'm going to. Let's make sure we have no faults in this system. It just shut the heat off as I'm trying to talk to it. It just made it get real cold. Can you feel it? All right, no codes. Live data. Don't know why I said data. I always say data. All right, so the two we want to focus on, blend door position and then climate control blend door position. It should be those two. The aux air blend door position, I believe that might be for the rear. Let me check that real quick. So I'm doing this one first. This is passenger side. This is the rear. You see it says R on it. And you watch the aux air blend door position feedback. As I move this, you can see that feedback position change. Okay, so it's a temperature blend door for the back. That's what that is. And we'll turn that one off. And then blend door position, I believe that was passenger side, so now we're on this one. I'll just leave that unchecked. That's the one we're looking at, the one that is uncheck marked. And as I move in the hot direction, you see that drop down to 60. That's a count, 60 counts. As I move full hot, and then as I move full cold, you see that number rise to 206. Okay. And then our climate control blend door position status, this should be passenger side, and this is, or driver side, sorry. This is the one that was not working on the Ford. Again, if I push up, those counts are increasing actually when I go hot, and decreasing when I go cold. So opposite of the passenger side. Full cold, 56. Full hot, 60, right? Full cold on the passenger side is 206. So looking at those two, sorry. And then, yeah, it's just the opposite number. It's just the way they're doing it. I don't have a explanation for you guys as to why they're opposite of each other than they just are, right? You see the numbers changing accordingly. So that's what we'd want to see on the scan tool doing this test. And again, I showed you guys the sound tests where you can, if you didn't have an enhanced scan tool, you can do those tests to listen to the mode doors themselves. And I don't know that we're going to be able to hear it. Driver's side, listen. Passenger side.
It's very faint, but you can hear it.
It is faint. So sound tests, and then I think the last thing I'd like to do with you guys is let's go in the studio, and I want to talk about the flow chart that Ford wants you to follow with this blend door problem when it doesn't move, and see if we can just kind of tie up the loose ends there. There was a couple of tests that maybe you might want to consider doing before attempting an 8-hour dash removal job. And you know, let's go in the studio and let's talk about it. So this final part for you guys, we felt like it was important because Caleb and I made a call on a temperature blend door actuator and never really checked the wiring or the computer or for a binding door. And so we want to cover that part with you guys. And then primarily, we want everyone to have a good understanding of this potentiometer position sensor mode door that's a reverse polarity motor. So there's a motor that reverses polarity that moves the component, then the door moves, then we have a feedback circuit, a potentiometer that's telling the computer mode door position. Now, the scan tool did report the position in counts, which is very unusual, but it is a way to report it. It can be done in percentage. In our case, it's done in counts. My preference when they give us potentiometer signals is just give me the voltage signal of it. It just makes it for easier understanding of what it is you're looking at. So mode door, reverse DC with a potentiometer, and so I pulled the diagram up first, and what we're looking at is exactly that. If you look up here, this is my left temperature blend door actuator component, and you see the motor part over here. You have a wire that extends to the computer here for the motor. It says motor positive, and then you have a wire that extends on there. It says motor negative. Now those will reverse polarity. So it should say plus/minus. In the computer, it does not, but that's how it works. So if we want the motor to spin one way, we apply power, say, to the yellow-orange wire, the top wire, and ground the blue-white wire below, or reverse it, put power to the blue-white wire and ground the yellow-orange. That's what we're doing for the motor itself. When we used to test reversible DC electric motors in the field, it was a simple test. What you would do is disconnect it, and you can take, there's multiple ways this can be done. This is one that I would have done. I would take a test light and connect that test light to ground, and then command the motor to turn. And what I want to see is that light to flash, either turn on constantly or flash, pulse. And then before I would say, okay, we're good on that circuit, if the light lights, that's great. That means that the computer is able to, on that circuit, if I'm connected to ground, that means it's able to apply a power. That's great. But that's only one. You're not done on that wire. That tells you your wire is good. That tells you the driver in the computer is good as far as the positive side, but you want to make sure that the negative side works. So the next step would be, once that light lights and you're happy with that test, the next step would be to switch your test light to positive and look for a ground, and that same wire that was power should now be a ground. So we move the motor again, either positive or negative, hot or cold in this case, and I want to see this light or flicker, which is going to tell me that that computer driver was able to ground the circuit. Does that make sense, Caleb? Reverse polarity, positive one way, negative the other, or power one way, ground on the other. If the light lights on both, how's that driver? That driver's fine. But that's one test. The second one would be, you would do the same thing on the other motor wire. You go to positive, check it there, switch it, go to negative, check it there. Make sure both wires can support power and ground. I have seen reverse polarity motor circuits fail in that they'll only apply power on one direction and not a ground on the other. So I've seen them fail that way. So it is possible that you can have that. And in that case, that would be testing the module motor circuit for control. If we have that and the motor's not moving, you're pretty much done. Would you agree? If I have test light that flickers on positive and negative on both sides, and that's carrying a current flow too, the wiring, the computer's fine. If that motor's not turning, that motor's faulty, or you have a bound up door, okay? In which case you would have some pretty heavy amperage. So that'd be one way you could check the motor. If we could get to the actuator, we can't get to the actuator, so we really can't do it that way. But we could go behind the HVAC module, disconnect it, and tap into those two wires right there and do the same tests. And that would tell you your module's fine. But when you do the tests up here, you're not checking the wiring in between. Now the wiring for this one, that module sits in the center of the dash, and the wiring's about 1.5 feet down. So unless you have mice, that have chewed that harness, the chances of being a wiring problem for, in this case, inside the car with a 1.5 foot piece of harness, slim to none. In fact, I've never seen it. But if you're checking it up here at the computer as we just described using your test light connected to different polarities, you are checking the computer still, but you're not checking the wiring. That's why down here is preferred. We can't get to that though, so we can't do that test. So that's one way. There's another way that you could do this, and that would be with an amp clamp and measuring current flow. And in this case, I can just pick either of the wire, put that to my lab scope, and then look for current flow as I'm going hot and cold on the dash. I want to see pulses of current. If you see that in both directions, you'll see a positive amperage, and then you'll see a negative amperage. Remember, it's reverse polarity. Amp clamps are polarity sensitive. So if I'm sending current this way, then my amperage is going to rise, right? If I'm sending current the opposite direction, so reverse polarity, if current's now traveling this way, then my amperage, that same thing, is going to drop. So you'd have a level up here, and you'd have a level down here that would be equal. And that would be how you could test the reverse polarity function of that motor. Go hot and watch it, and then go cold and watch it. You'll see amperage one way and then negative amperage the other. What's that tell you about your drivers? What's that tell you about the wiring? It's all good. You can't have, current flow is actually a better test at the module because you can't have an open in the wire and have good current flow. Because what do you need to make current flow? You have to have a complete circuit, a power, a circuit, complete path, and a ground for current to flow. So if you're measuring current up in this location behind the HVAC module, which is where the manufacturer flow chart, by the way, has you doing all of your tests for this B2266, I believe that's the code. It has us doing all the checks at the module. Why? Because you can't get to the actuator. It's an 8-hour job to get to the actuator. That's why you're not doing any of the checks down there. So you're not going to see this amperage test in the flow chart, which I'm about to show you next. They're having you do resistance measurements, typical flow chart. But that amperage measurement, again, if you have current flow, you have to have a complete circuit for current flow to be there. If I see amperage on my, I'll just draw a little kind of triangle ramp. That's not what it's going to look like, not for an electric motor, but just for a visual. If I see that, how is my wiring? How's my motor? How's my control? How's my module? It's all good. It's all good. That motor should be moving. You want to see, again, though, the reverse polarity for this. One way it'll go positive, the other way it goes negative. If you have an open in either of those circuits, it's not going to happen. If you have an open in the motor, it's not going to happen. What's not going to happen? Amperage. It's not going to be there. Or if you have driver issues, amperage is not going to be there. So if amperage is there, how's your driver? How's your wiring? How's your motor? It's all good. Does the test light do that? The test light's a little different, isn't it? The test light down here, when we measured here and here, tells us wiring is good, tells us driver is good, but does not check the motor. Okay? It's just process of elimination. If the motor doesn't turn and your wiring is good and your module is good, your motor is bad or the door is frozen. But if you measure up at the computer, here and here, because you can't get down here, which we can't, using our test light, again, connected to positive and negative, does that check the wiring? It does not. Couldn't we have an open in the wire here and still have a good result on each of the circuits? And the answer is yes, which is why doing the test light test up here is not as valuable as it is down here. But does it check the driver? Yes, it does. And if you can do that test, honestly, it's this, guys. If you want to make sure your HVAC control module is good before you put 8 hours of time into a customer's car or maybe your own car, that's the test I'd recommend. Everybody's got a test light. Take your test light, connect it to ground, move the door, make sure it lights, then connect it to positive, move the door, make sure it lights on both wires. If it does, how's your module? Module's good. Could we have a wiring problem in between? Yes, we still could. Could we have a faulty blend door? Yes. Or a frozen door? Yes. What are you doing to address the wiring, a frozen door or the motor? What are you doing? You're pulling the dash apart. So really, from this point, Caleb, we really don't have to go any further. That's the final piece that I believe should have been done by us to make sure that that driver was functional before making that call. What did we do? We kind of rolled the dice. We kind of went with common problems. You know, we did some deductive reasoning. We said to ourselves that, you know, the rest of the mode doors work. This one is not. We have a position, but it's not moving. It could have been a faulty HVAC control head. I'm confident it was not. If I was playing the lottery, I would absolutely bet a large amount of money on the blend door actuator being faulty. But that's not what this is about, right? And that's why I felt like we needed to fill in the gaps a little bit here for you guys at the end, saying that don't be a parts changer is our slogan, right? And we want to make sure we're not being parts changers. And we really kind of left out some details at the end of that video. And it was primarily because of the work involved just to do these final steps. In our eyes during that day, it just wasn't worth it. I think that was the day before we went to Dolly Sods for our Dolly Sods trip. So Caleb and I, if you guys haven't seen our Dolly Sods trip, I know it's an hour and 18-minute video of us camping, but it was awesome. And you know, Caleb and I had camp on our minds.
We did not want to be there.
We did not want to be there.
We had to go to Dick's to get food.
Yeah. So my friend Steve, who I play hockey with, we mentioned him too earlier. He's going to be watching this finally. And Steve, I'm still comfortable, Steve, your temperature blend door actuator's faulty. We're just, you know, covering the minute details here for our community to make sure that, you know, we're not being parts changers here. So that what I just described would be the motor circuit tests. As far as the potentiometer circuit, we're looking at right here a typical 3-wire potentiometer. The only difference with this one from others you've probably seen is they're showing a resistor here and a resistor here. They're fixed. That's not an issue. It's a voltage divider circuit. It's still going to work the same way. You're still going to have a 5-volt ref, a signal, and a ground. And so looking at this, it is helpful to know what is what. And I thought I'd take a second to describe to you guys what I do if I have a wiring diagram like this and I'm trying to figure out what's what, and I don't have a good description inside. So if you don't have a lot of our diagrams, they don't give us this stuff over here. So all they give us is the wires, the colors, the pin numbers. I don't know what's what. I do know my fundamentals, 5-volt ref, signal, and a ground. How do I know that? That's how every potentiometer works. Again, I had mentioned this before. This is Chapter 7 material in my book. In fact, I want to go there just real quick. This is from Chapter 7. This is a typical potentiometer circuit. We have a 5-volt ref, comes from a 5-volt regulator, and we have a constant 5 volts that comes this way and runs across a fixed resistor on its way to ground. So what we would have on this is we would have a voltage that would start at 5, go to 4, 3, 2, 1, and 0. Your direction of current flow would be this way. Okay, and then what we have is essentially a voltmeter in here. There's your voltmeter positive lead, there's your voltmeter negative lead. Your voltmeter is not supporting current flow. This would be on a hinge, and the wiper, when it would sit down here, would be low voltage. See, it's pointing at about 1 volt, so we would be feeding back, that's your feedback circuit, a 1 volt signal to that. If that wiper is all the way up here, that would be an indication of, say, 4.5 volts, and then every range in between. That's why potentiometer circuits, when you look at them, they're nice and smooth as the wiper moves up and down. That's what you're looking at in these. There's a drive-by wire on a Ford, 2 potentiometers, increasing and decreasing signal. That's what you want to see, okay? Standard stuff here, guys. That's how we know. We learn our fundamentals. We come to a car that is now using a potentiometer as a climate control temperature blend door. But it's the same checks that we've learned how to do on a throttle position sensor in 1985 on a Dodge Aries. I'm speaking of my own experience and maybe my first time looking at a potentiometer in the field. Sure, I learned about them at school, and then, you know, I started in the field full time in '93, so there were plenty of 85 cars still on the road. So that's me. Here I am plugging in 1985 Dodge Aries knowledge of a potentiometer because I tested one now on a 2012 Navigator climate control temperature blend door. I mean, that's pretty cool. Fundamentals, guys. That's where we're at. So looking at the diagram, again, let's say hypothetically this stuff's not covered with us, right? This stuff's not covered. They don't give it to us. A lot of our diagrams, they don't. Can you tell me what the 5-volt reference and the ground is on this circuit? Well, it's pretty tough. I can see a splice here and I see a splice here. So I know those two are my 5-volt reference and ground. The other tip for you guys I can give you on wiring diagrams is when you see a pointer like this, you see the little arrow. The arrow on a potentiometer circuit is always the signal wire. So I know right away that this wire right here, that one is my signal. Now what I don't know is the reference and ground. I know they're there. I don't know which one's which. So looking at the diagram, let's go full screen now. Looking at the diagram, you can see that we have some shared circuits. Let's look at this one first. Let's look at that splice. Comes up to this left mode door actuator. It splices off, goes to my right mode door actuator. It splices again and continues down, goes to the auxiliary climate control assembly. That's the rear. And so if we didn't cover that in the video, I think I had mentioned, why is the auxiliary not changing maybe? Remember you saying that in the edits, Caleb? I believe that was, I never turned the rear on, which is why we never saw a data PID change. I'm thinking that right now. Sorry, side note, probably is correct though in what I'm thinking. Another splice comes down here. This is part of the right temperature blend or actuator. That's the right, what's this one? I can't read that. So anyway, multiple circuits. Which one is that? I'm not sure yet. Following it this way, again, forget that. You can't see any of that. Goes off the page. Next page. What color was that wire? Brown, white. Brown, white comes down here, splits, and goes to two more. That's the auxiliary door actuators. Two more potentiometers. All right. 5-volt reference circuits, this is another piece that I teach. 5-volt reference circuits are never shared externally by potentiometers and thermistors. What's a thermistor? It's a temperature sensor. Works a little bit different. This will be my chapter 6 material. So temp sensor, there's a temp sensor here, there's a temp sensor here. Let's go back. Let me erase this ink. Let's follow the other one. Remember, we're talking about two different ones. We followed that one. We're still not sure. Could be the ground, could be the 5-volt reference. I'm not sure because all those potentiometers can share 5-volt reference and ground. Let's follow this one now. See where this one goes. And, you know, it goes to the opposite side of the potentiometer there. So following this one down there. Follow this one off the page. It comes up here, goes to some LED lights, comes down to this splice, and bam, goes to a thermistor. That is a ground. How do I know that? Fundamentals, guys. You cannot share a 5-volt reference externally with a potentiometer and a thermistor. Can't be done. So we can share grounds between potentiometers and thermistors. And so, guys, all I've done is just told you by looking at a tie-in with a thermistor on this page to a splice that goes to a potentiometer on this page, that has to be my sensor ground. No question about it. No question about it. For more info on that, guys, please, you owe it to yourself if you're interested in this trade to sit in some of my classes. This is chapter 6, chapter 7 material that I'm talking about here. I also cover this again in chapter 9, which is the 5-volt reference circuit. I'm just learning these fundamentals. So when I look at a wiring diagram, I can make these kind of determinations when I don't have that info inside the computer. But it is there. It is there on this one. Let me show it to you. Let's erase the ink. On this one, it's pretty easy. Some of you may have caught it early. Again, when we started, we said, we don't know what that is. We don't know what that is. Well, follow this. That goes off the page. What is that? That's brown and white. That comes over then to this splice, comes over this way. Brown, white is VREF. That's my 5-volt reference. That's exactly what we said. And then this one, this goes off the page as well. It's a gray and blue. It actually comes over to 2. It actually comes back on 6. And then 6 says signal return. So let's be clear about this signal return term. A lot of people in this field, even professional technicians, use this term incorrectly. A signal return is a ground. It is not the signal returning to the computer. A lot of people would say, remember when we started, I said that this middle wire is my signal wire, right? A lot of people would say, when they're talking about this with other technicians, they'll say, oh, on my signal return wire, I saw a 0.5 of a volt all the way up to 4 volts, basically a potentiometer signal. They're using the wrong term. That's not the signal return. That is a signal wire. Signal return is what? A sensor ground. Signal is different than signal return. So when you see signal return on a wiring diagram, that's not where the signal's returning to. That's not the, well, it technically is, but that's not where the signal is being sent to from the potentiometer. That's a ground. Signal return, current flow return. Get used to that terminology. So that's it. I mean, there's your potentiometer. If this is my 5-volt reference circuit and this is my ground, then when the wiper's pointing this way, the voltage will be high. And when the wiper's pointing this way, the voltage will be low, regardless of the external resistors there and there. Doesn't make a difference. Okay? That's your circuit. Make the motor move. How do you make the motor move? Well, do your checks as we described. If there's nothing there in your HVAC module you think is faulty, you checked your wiring and it's good. If you want to make that motor move, you can jump that motor to power and ground and make it move while you're monitoring voltage on the signal wire. Turn the key on, monitor voltage, or this is what the flowchart has you doing. It actually has you doing this up at the computer. I'll just cover it with you real quick here. If you wanted to make the motor, force the motor to turn, they actually have you taking this circuit, disconnecting it, and then they have you connecting an ohm meter essentially from the signal wire, that's this one, brown and blue, taking an ohm meter here to the signal return. So you're essentially going from there to there. And then they have you taking and jumping the motor circuit 21 and 22 with power and ground, and then reverse polarity, ground and power. Make the motor turn. What do we want to see resistance-wise? Remember, because we have the module unplugged, so we're not going to see voltage, but resistance-wise, we want to see resistance change. It should drop if I'm going between the signal and the signal return. If I'm going between the signal and the reference, depending on which way it moves, I said it should drop on the signal return. It could drop and rise depending on which way you make the motor turn. And it would be the same way here. If you put your ohm meter between here and here, it's just going to be opposite of if you were between the signal and the signal return. Make the motor move, watch resistance change. And so I'm not going to go through the flowchart with you guys. I think that's enough. I will show it to you briefly, just in that I want to show you a bird's eye view of what they're having you do. Flowcharts, guys, when you follow flowcharts, don't disregard them. I know that you guys hear me really get on flowcharts and make fun of them, and I still do. This is a horrible flowchart. They're all horrible, but I still use them as a guide. It tells me what's in here. And this one, it gives me normal operation. It talks about also doing a calibration test. So there's a calibration cycle that's mentioned in here. That's something that Caleb and I maybe should have considered on our car. Now, we know calibration was not an issue because the mode door never moved. If you have a calibration issue, these are learned values on this car. Guys, I'm not going to get too deep into that, but where did I get that information from? from the flow chart. I read the flow chart. Something else with this chart I want to point out, if you were to follow this, and you can see where we are, we're at the HVAC control module. This is the HVAC control module connector. We're disconnected, we're doing resistance measurements. If you're going to do this and follow this chart, don't follow it blindly. Make sure when you're following a flow chart that you understand what you're checking. Well, let's just cover one of these together, okay? What's it say in this first step? Feedback potentiometer total resistance is what they have us checking, and they want me to go between circuit LH111, which is a brown and white wire, harness side of the HVAC module, to the circuit RH111, which is a gray-blue on the harness side as well. So don't just look at the picture and pin numbers, because it does give us pin numbers. It says pin 10, so that's 13, this would be 12, this is 11, this is 10. All right, there's 11, pin 11, there's pin 10. We could do it that way, and then take your resistance measurement, and this is what people do. I've seen it so much. They do the measurement, and then they don't even know what they're measuring. What's it say? It should be greater than 500 ohms. If it is, go to N3. If it's not, go to N2. What did you just measure? You have no idea. You're just following this chart blindly. What should you be doing? When you pull up a flow chart, you have these cryptic letters in there for a reason. Check this out. On the flow chart, or on the wiring diagram, look at this. LH111, RH111. It's a designated wire. LH111 is brown and white, just what the flow chart said. RH111 is gray and blue, just what the flow chart said. So now I know what I'm checking. I'm disconnected here, and I'm measuring resistance between the 5-volt reference wire and the signal return wire of a potentiometer. But here's the catch with this one. How many potentiometers did we talk about? There's 2 on that page. Right, those are these guys up here. There's 2 more down here. There's 2 more over here. And then we got some LEDs up here. So we have 6 different potentiometers all sharing the same reference and ground. And so it's a parallel circuit. You have not just one potentiometer that you're measuring resistance between, right? So if that was a 2K ohm resistor, whatever, you're going to read 2,000 ohms. But we're putting more in there, aren't we? 2, 3, 4, 5, 6. When you add resistance in parallel, total resistance drops. So depending on what each of these are, do you understand the number now, why it should be more than 500 ohms? Because 500 ohms seems like, let's go back to the chart, 500 ohms seems like such a low number when you talk about measuring the 5-volt, measuring from a 5-volt ref through a resistor to ground. A lot of these are about 5K ohms a piece. And you're like, well, it should be greater than 500 ohms. That's such a low number. Why? Why is that number so low? Because there's 6 of them in there. And what do we do? Parallel circuit laws, fundamentals again. What do we do when we add resistors in parallel? You drop total circuit resistance. So do you guys understand? I'm not going to do each step of this flow chart, but do you understand how important it is to know what it is you're doing when you're measuring stuff, following a flow chart? Don't just follow it blindly. If I'm following that blindly, I have no idea when I go to the next step why I'm going to the next step. I do now because I know what I'm doing. I'm measuring feedback potentiometer total resistance. Why would they say total resistance? Because it's total resistance between 6 different potentiometers and a couple of LED lights. I know what I'm doing because I'm following the flow chart combined with a wiring diagram combined with common knowledge, fundamentals, guys. This is the kind of stuff, it'll take you far. I just had a comment the other day from someone. It's like, yeah, I made a comment about we're working on a 2018 Duramax CAN system fault. It's been one of the coolest case studies we've done in a long time. I posted about this video coming up, and someone commented, oh, wait till the electric cars come. You guys are, you know, I forget the comment. It wasn't like we're going to be lost, but it was essentially saying, you know, there aren't going to be technicians that are going to be able to work on them. And that's, I think, completely wrong, because what we're doing now is exactly what you're going to see on an electric car. An electric car. What's it gonna have for a mode door position for a temperature blend door? What are they gonna have? It's gonna be the same thing. It doesn't matter that the car's electric. You know, it's still an electric system. It's all the same stuff. Learn your fundamentals and we'll be ready for anything. I mean, that's the lesson there at the end. I don't think there's anything else I want to cover with you with this flow chart. I'll just kind of scroll here and you notice what we're doing here. We're doing resistance measurements across the board at the connector. The final part, they're having you do resistance measurements. And I had mentioned this a little bit about jumping the motor. Look, they're having you use fuse jumper wires and then jump in the right pins. Why? They're having you use the power of the module and the ground of the module, the main power and ground, as your source, and then your reverse polarity, is that a word? Reverse polaritying?
Reverse polarizing? Is that it?
Reverse polarity changing the controls, and then you're watching your ohm meter change as you're moving the motor. So that's what Ford has you doing in this chart. It's actually a decent chart, but I don't like resistance measurements. I think what we covered with you guys as far as the looking at the wiring diagram is better. In particular, if you just want to be 110% that this mode door actuator is faulty. I really think the key, Caleb, if I could redo this and think about this on that car, I probably would have taken the HVAC control panel off. That would have taken us maybe 10, 15 minutes to pull that out. And then I would have grabbed the motor control wires on pin 22 or 21 and put an amp clamp on there. And then I would have exercised the motor. And what we would have seen is if the wiring and controller were good, and the motor itself too, we should have seen amperage changes there. And if we didn't see amperage changes there, then that could indicate the motor circuit's open. It could also indicate a wiring issue here or a driver issue. And so if we didn't see motor amperage changes there, then the next step that I would have done is the test light test that I mentioned to you guys earlier, switching my polarity with my test light, moving the motor hot and cold, and making sure my test light lights on both polarities on both wires up at the control panel. And if I saw that, then the only thing left is wiring in between or actuator itself, and you're pulling the dash apart anyway. So that last part, we should have covered that. We did not. That's why we brought you guys here to the studio. Caleb, thanks for being with me through this. He was my student through this. He's not only behind the camera, but he's watching on the TV screen as well and learning. And we're just happy to bring you guys along with us. We'll be doing a little bit more stuff here in the studio here for you guys on YouTube for sure. And of course, this is what we do on the premium side of things. We bring you into a classroom type environment and just fill in the gaps like we can't any other way. It's nice to be able to sit down and do this with you. Please check out my website, www.ScannerDanner.com. ScannerDanner Premium, we offer a free trial, 14-day free trial. Right now we have about 430 training videos on the premium channel with 250 or so that are classroom lectures where I'm in the classroom. I'm teaching through my book, through my material, teaching you your fundamentals. Guys, if you are interested in this part of the field, this is the stuff for you guys. You can learn at your own pace. It's $11 a month after the free trial, and most of the people that join up stay with me for a long time, and we continue to bring new material. That 2018 Duramax I just mentioned, that CAN network issue, that's where that guy's going. So premium members, look for that. It'll be up soon, a couple weeks before we'll have part one of that one up. So again, thank you guys so much for joining us. We'll see you next time.